Bismillahirrahmanirrahim. I am Asma Shehzad, Head of Chemistry Department, Defense Degree College for Women. The topic I have selected is intermolecular forces. I hope the students will be able to find out the answers of the questions which are given at the end of this lecture. Intermolecular forces. John D. van der Waals, a Dutch scientist, was the first who introduced the intermolecular forces. According to him, there are two types of intermolecular forces: repulsive forces and attractive forces. If the repulsive forces are dominant, then the molecules move apart, and if the attractive forces are dominant, there exists a certain force of attraction. It depends on the nature of the atoms which are present in the molecule, that what type of attractive forces are. Van der Waals categorized the forces into two groups. Van der Waals forces are dipole-dipole forces, dipole-induced dipole forces, London forces, and the other intermolecular forces are ion dipole interaction, ion induced dipole interactions, and hydrogen bonding. We will study the dipole-dipole forces, dipole-induced dipole forces, London dispersion forces, and hydrogen bonding in this lecture. What are dipole-dipole forces? Dipole-dipole forces are due to the interaction between the oppositely charged poles of polar molecules. Means, when two polar molecules are present, they develop a force of attraction. The partial negative end of the molecule attracts the partial positive end of the other molecule, and a force of attraction which is called dipole-dipole, because the molecules are now having two poles. The forces of attractions are present between the two poles. That is why these attractions are called dipole-dipole forces. They are only 1% effective as covalent bond. They depend on the electronegativity difference between bonded atoms and the distance between the molecules. These are present mostly in HCl molecules and in chloroform molecules. In case of HCl, the partial negative end, that is the chloride ion of the molecule, attracts the partial positive hydrogen ion of the other molecule and develops a force of attraction. Dipole-dipole forces of attractions are dependent on the distance also. If the distance between the two different molecules is greater, just in case of gases, then these forces are weaker forces, and if the distance between the two molecules is lesser, then these forces are stronger, as in case of liquids. The thermodynamic properties means the properties which are related with heat, like boiling point, melting point, heat of vaporization, heat of sublimation. They are also related with dipole-dipole forces, those molecules which have greater thermodynamic properties, they have stronger values of dipole-dipole forces. The next force is called dipole-induced dipole force. Induced means you have inducted intentionally. These forces are between polar molecules having permanent dipole and the molecules having no permanent dipole. These are also called Debye forces. The polar molecule induces a temporary dipole in the neighboring non-polar molecule and makes the neighboring molecule a polar molecule. The next forces are called London dispersion forces. The momentary force of attraction created between instantaneous dipole and the induced dipole is called dipole-induced dipole interaction or London dispersion forces. Basically, these are present in non-polar molecules, for example in helium atoms, which are symmetrical non-polar molecule atoms. When they are moving as a gas, they come close to each other. The electrons of one atom repels the electrons of the other atom, and in this way the repulsion creates a polarity in the molecules and a polar structure is formed and the symmetry of the atoms is distorted. This is a very temporary dipole created, or in the dipole is formed only for a very short while. Any other nearby molecule which is not an induced dipole, when comes close to the induced polar hydrogen atom, it gets polar and the previous polar atom becomes normal. In this way, at one moment one atom is polar and at the other moment it is non-polar. So it is a temporary dipole and it is created, and the electron density is at one moment symmetrical and at the other moment non-symmetrical. So it is also called as instantaneous dipole moment, the instantaneous dipole or London forces. London dispersion forces are present between all molecules, whether they are polar or non-polar. These are very significant for non-polar molecules like chlorine, hydrogen and noble gases. That is why we can liquefy the noble gases. These forces are weaker than dipole-dipole interactions. These are stronger in molecules that are easily polarizable. Larger and heavier molecules exhibit stronger dispersion forces than smaller and lighter ones, like fluorine is a gas while iodine is a solid at room temperature. What are the factors affecting London forces? There are two basic factors which affect the London dispersion forces. These are size of electronic cloud of atom or molecule. The second is number of atoms in non-polar molecule. Size of electronic cloud. How it affects the polarity. Polarizability. Basically, polarizability is the quantitative measurement of the extent to which the electronic cloud can be distorted or polarized. Means, larger the size of the atom, greater is the distortion and stronger will be the London dispersion forces. This is very evident in case of iodine. The second factor is number of atoms in molecule. Greater the number of atoms in molecules, greater is the polarizability. For example, in case of ethane, we have only 2 carbon atoms and 6 hydrogen atoms, and the boiling point is minus 88.6. That means it is a gas. Less forces of attractions are present between the two ethane molecules. They are existing independently and are far apart from each other. Whereas in case of N-hexane, whose boiling point is 68.7 degrees, that means it has larger number of atoms in the molecule, 6 carbon atoms and 14 hydrogen atoms, which gives a larger area of interaction with the other molecules. So it may develop forces of attraction and hence has a higher boiling point. Next factor is the surface area. Larger the surface area, greater is the dispersion. For example, in N-pentane, which has a straight chain and has a boiling point 309.4 degrees, while the neopentane, which has a spherical shape and has a boiling point 282.7 degrees. Means a straight chain has a larger surface area where the other molecules can interact, whereas the neopentane, which is spherical in shape, has lesser surface area for the other molecules, so it has a lesser boiling point. Next is the hydrogen bonding. A very important force of attraction. Hydrogen bonding is the electrostatic force of attraction between a highly electronegative atom and partial positively charged hydrogen atom. The electronegative atom is usually fluorine, oxygen or nitrogen, which are present on the 5th, 6th and 7th A group of the periodic table. On the top of these 3 groups, these have some exceptional behavior and have some special nature. This is the picture of hydrogen bonding in case of water. Hydrogen bonding is present in water. One water molecule has one oxygen atom and two hydrogen atoms covalently bonded, whereas the oxygen atom has two lone pairs of electrons. These lone pair of electrons make oxygen atom very electronegative, and it starts attracting the partial positive hydrogen atom of the other neighboring molecules. So an extra force of attraction is developed, which is mostly represented by dotted lines, is the hydrogen bonding. Types of hydrogen bonding. Hydrogen bondings are of two types: intermolecular hydrogen bonding and intramolecular hydrogen bonding. As the name shows, intermolecular means the hydrogen bond present between two molecules. Bond between two different molecules of the same or different substances. For example, the hydrogen bond between ammonia molecules, between water molecules and alcohol molecules, and between hydrogen fluoride itself. In case of intramolecular hydrogen bond, bond between hydrogen of highly electronegative atom present in different bonds within the same molecule. For example, orthosalicylic aldehyde, orthonitrobenzoic acid, and DNA. Hydrogen bonding has some specific effects. It causes higher boiling points in ethanol as compared to diethyl ether. In case of ethanol, that is alcohol, C2H5OH, has a hydrogen bond due to the presence of partial negative charge on oxygen, and in diethyl ether there is no hydrogen bonding. Hydrogen bonding causes water as a liquid, whereas hydrogen sulfide as a gas. Although oxygen and sulfur belongs to the same group 6A of the periodic table, but oxygen is more electronegative as compared to sulfur, so it develops a strong force of attraction in the molecule of water, which makes it a liquid, as extra force of attraction makes the distance smaller and the molecules of water come close to each other. Whereas in case of hydrogen sulfide H2S, the sulfur belongs to same group but has less electronegativity, which makes it a discrete molecule and it exists as a gas. Hydrogen bonding causes density of ice lower than density of water, which is a very supportive thing for the aquatic life. The fish underwater, undersea, the fish in sea exist during winters, when the ice makes a blanket on the surface of the water. The water molecules in case of ice arrange themselves in a regular network of structure. This arrangement occupies more space the empty spaces are created in the structure of water throughout the container or area. That is why when water freezes, it occupies 9% more area. That means it occupies more surface and its density becomes less. That results the ice floats on the water. Hydrogen bonding is important in hydrogen fluoride and in water itself. Hydrogen fluoride is having zigzag structure due to the strong electronegativity of fluorine. The hydrogen atom is more attracted towards the fluorine, and the small size of fluorine makes the molecule of HF very small, and it starts attracting the fluoride ion of when HF attracts the hydrogen atom of the other HF, and the structure becomes very close, and a zigzag pattern is developed, which makes the hydrofluoric acid very low in strength, because the hydrogen atom is not able to be removed easily. The hydrogen fluoride is unable to lose its hydrogen, which makes it a weak acid. Hydrogen bonding in DNA. This is the example of intramolecular forces of attractions. Means in the DNA, the different bondings which are present, the nitrogen, hydrogen and oxygen are making different bonds in different areas and giving it a double helical structure. In the end, I hope you people will be able to find out the answers of the following questions. Why do some solids dissolve in water but others do not? What happens when noble gases liquefy? Why ice floats on the surface of water? Why are some substances gases at room temperature but others are liquid or solid? Thank you.